I want to find the z value such that the area under the standard normal curve, it should be curve, between 0 and z is 0.2123. So they gave me the area of the curve, which is sort of like when the uniform was asking us about the 30th percentile. They gave me the area in the curve. I need to know the rest. So from 0 and then to some z value. And they didn't put negative z, so I'm assuming that it's this positive z somewhere up here. I don't know what it is exactly, but somewhere up there. And then they told me that this region in here is 0.2123. So they gave me the opposite of what I had before. Well, I do know that it's a standard normal, so that means that the mean is 0 and my standard deviation is 1. And we have our z-score formula that tells me z is equal to x minus mu over sigma. So let's fill in the pieces that we know. We know that we have a value for this z, or well, the area for it. Yeah, that'll be fine. And if this is the area, where did we get our areas before? From the table. But the table gives me the area from a point down. So this is how much is above my mean. What's the area from 0 below? 0.5, 50%. So if I want to be able to find that z value, I need to do 0.5 plus 0.2123. So that gives me, it's half, because the mean cuts your distribution in half. So we've got 0.7123. So that's the area I actually need. So we're going to have to reverse our process. So let's go to our table. And we know we're looking for a positive z-score. And we need to find 0.7123 on the table. So let's figure out, here's some 0.7s and 0.7. So we start with our 0.7s in here. And if I look, in there is where I find the 0.7123. So let's put our pieces back together. That puts me in this column where I've got the last digit was a 0 or a 6. The first two digits are the 0.5. So what z-score is that? 0.56. So we're going to take that down. And that means that the z-score that goes along with this is the 0.56, because I put my pieces together. Sure. So you have to add those two pieces together. So you're going to add the 0.5 and the 0.06 together to get your total z-score. So that's the z-score that goes along with it. And then, well, we're not exactly sure what x is, but we know that the mean is 0 and the standard deviation is 1. So then that tells me, all right, I looked it up. 0 doesn't do anything. So the value that I am actually interested in, because 1 just kind of goes away, is 0.56, gives me just the value that I was interested in. So right here is 0.56 that goes along with that area that kind of cuts it off for this portion of it. Questions on that? Yes?
Why did you add a 5?
Because remember, your table only gives you the area to the left. So if I want a positive z value that's above 0, I've got to figure out the total area below that amount. And we know that our mean cuts our distribution in half, so half of our probability is below it. Does that make sense? Other questions?
So 0.56 is the shade area.
The 0.56 is the value of z that gets you a total area of everything up to that point. Yeah? Yep. Questions on that? All right, so as much fun as it is to go surf through the table, we do have technology to help us as well. We do have to use a slightly different function. I'm going to put it up here. When I know an area, we're going to use a function that's called inverse norm. And it's going to want the area to the left, the mean, and the standard deviation. So in our case, we're going to have, again, it needs the total area to the left. So what's the area up to that point? That's still the 0.7123. And then we have a mean of 0 and a standard deviation of 1. So, and we can find our inverse norm in the same spot as normal CDF. So if we go to our distributions, right underneath normal CDF is the inverse normal. If yours looks like mine, it's going to prompt you for each piece. And it's going to say, okay, what's the area? Well, the area to the left is the 0.7123. And then we've got our 0 and our 1. If yours just pops up inverse norm, then it's going to want you to put it in with parentheses and commas in between. So just like normal, we'll put in our area, comma, the mean, comma, the standard deviation. And then we can hit enter, and it's going to pop it up. Now, notice this doesn't give me exactly what the table did, but your table is limited to what it can give you. And then for these, since your calculator is going to give you more decimals and be more exact, you can just round to 2 decimals because that's the z-score you'd get off your table. We can't get more than 2 decimals from the table. Questions on that? Sure. Yes. I'm going to show you how to do it in there. All right, so let me do this one more time. So I'm going to go to the distributions, and right under normal CDF is my inverse norm. And then it's going to ask you for your area. And your calculator always assumes the standard normal to start with. And then once we're not in standard normal, we'll have to change the mean and standard deviation. But for now, we should be good. And then we can hit to calculate it. To start with. So if I want to find z sub alpha, and we're going to let alpha equal 0.025, that means I want to be able to find the z of sub 0.025. It's telling me that's the amount in the right tail. So if I was to look at this, in my right tail is 0.025. And I want to know what's that z that goes along with that. Well, we have a few methods that we can do to find that. One is I can say, well, if that's how much is in the right tail and the total area equals 1, what's the area below that z value? So this side would be 1 minus 0.025, which is 0.975, I think. Yes? So I can go to my z table and I can say, okay, where is 0.9725 if I'm going to use the table? So let's look in the nines. 0.97. Is there a 2.5?
It's just 0.975.
975. Oh, yes. I don't know why I got the 2. 975. All right, so that's in here. So I'm going to go over to the 1.9 row is where it starts. And it puts me back in the column of the 0.6. So if I add those together, what's the z-score? 1.96. So I can say from the table, I got that z alpha is 1.96. That goes along with the area in the right tail. So this is, I went to the table. I could also say inverse norm. And we could do 0.975 with a 0 and a 1, and it would also give it to us. So let's try that. If I go to my distributions, inverse normal, 0.975, and a 0 and a 1. So again, it's going to give you a few more decimals, but we want to round to the 2 decimal place, so we'd get 1.96 from it as well. I'm going to put that we got 1.9599 and say 1.96 when we round. Yes. So let's go to our distributions and get our inverse normal. Tell it the area to the left.
I'm going to go with the table.
Okay.
So the answer that we got for that was 0.975.
Mm-hmm.
So you go to the table and you find 0.975 and then you go up and then I go, okay, that's what
You're reversing the process because they gave you the area, a number inside the table. Where did that come from? So we got to find the numbers on the outside of the table.
That's what I was confused. I was going to the outside and trying to find it that way.
Nope, it's the inside probability this time. And then once we get all our numbers punched in, we'll just calculate. So you get it to work. Yeah.
Why do we do 1 to